to it, huh? Let's see. We got 48 minutes and so much to talk about and so much to cover, so we're going to have to hurry. Welcome. How you guys finding the show? Awesome, right? Pretty good? Okay. My name is Josh Long. You can tell because it says it up there. My Twitter coordinates is at StarbucksMan. How many of you are on Twitter? Okay, I'm expecting at least like 5, 10 new followers, guys. Come on. And then email, very important. Okay, if you leave this room more confused than when you came in, at least now you have recourse. Please feel free to reach out to me, josh.long@springsource.com. I'm the Spring developer advocate for all the open source Spring technologies. So please, if you have questions, feel free. And again, slideshare.net, Josh Long. These slides will be there. I'm the author on some 4 different books on Spring at this point, and I'm working on my 5th, which is Spring and Cloud and good stuff with Manning. I'm also a contributor to several different Spring projects, not the least of which are Spring Integration and Batch, and the original Spring Hadoop stuff, and Spring support for other projects. This is an out-of-date list at this point. And every Tuesday, which is today, for those of us who are jet-lagged and keeping track, I put together a roundup on springsource.org called This Week in Spring. It's just a roundup of all the great sort of community content, blogs, tutorials, etc. Feel free to check that out. All right, so we have a lot to cover. Just show of hands, how many of you are using Spring? Goody. Spring 3.0? Okay, Spring 3.1? Okay, so what we're going to do is we're going to very, very, very briskly move through Spring 3.1, 3.2, and then look at 4, which is Spring.next, okay? Broadly, Spring 3.1 was released in December of 2011. We'll look at that first, of course. Last year, at the end of the last year, we released 3.2, and we are expecting to release 4.0, the next iteration, the next jump, at the end of this year. So, okay, Spring 3.1, for those of you who haven't seen it yet, introduced a lot of different things. It introduced a revised environment abstraction. It introduced something called profiles. Profiles let you, tag different beans as belonging together, and they can be enabled or disabled in groups. We released a cache abstraction, very, very useful. Better, very, very nice Spring, Servlet 3.0 support inside of Spring Mvc. We released, updated compliance levels for all these different APIs, including Hibernate and JPA and Java SE7. Looking at profiles a little bit here, okay? So profile solves a kind of a very common use case. Suppose I have an application, and the application connects to a data source, and the data source changes from one environment to another. You might imagine I test against my local in-memory database in development, and then perhaps in Q&A or integration testing or whatever, that application connects to a different database, and then in production, it's an entirely different database, right? You might have something instead of an in-memory database in development, you now have a data source bound to a context like JNDI or some sort of cloud context, okay? Looking that object up is, it's quite a feat. It's not just a matter of plugging in different string values for the username, password, host, and port. It's you might very well have an entirely different database, altogether. So here's an example. I have in the XML, I have beans. There's a parent beans element at the top here, and then inside that you also have beans elements. Okay, and the beans elements have the profile attribute. The profile says that all the beans contained herein belong together. They are part of the production profile. And I can tell Spring when I start up the context that I want the beans in this profile or that, or the names are arbitrary, by the way, and you can use as many as you like. So you might have 10 profiles. I wouldn't recommend it, but you could. And you could conditionally enable or disable 2 of them at a time, or 5 at a time, or 1 at a time, right? There's no restrictions here. So the idea is here, when I deploy my application, I have the configuration for each environment. I can test each environment, but I only turn on 1 per environment. This avoids the sort of inherent flaw of having some sort of build system that is dependent on the environment you're deploying to. You don't want to have a dev build and a production build because you can't certify. You want to be able to take one build, certify it, and then push it all the way to production. Makes it a lot easier. Okay, I wanted to get that out of the way just so we can kind of go into this. Let's look, by way of code, let's kind of look at what a common application looks like today. It's very typical to have some sort of service tier. Here's a very, very simple POJO, plain old Java object. Business logic, right? You can see very, very basic rudimentary service methods there. Very typical. I want to be able to work with Hibernate 4, Hibernate of some sort. JPA perhaps. In this case, I'm using Hibernate. So it's very simple to then inject a reference to that Sessionfactory that I need to be able to work with it. And in my methods, I can actually just, create my objects and then persist them with Hibernate. I'm not going to rehash the details of Hibernate here. I want this method to be transactional, right? Of course, I want all the things that happen inside this method to either commit and succeed entirely or to roll back. I could optionally put the add transactional at the class level, in which case all methods inherit the behavior. I might, in some other methods that have resources that are responses to queries, cache the results, right? It's very, very expensive to constantly look up data inside the database. So short circuit the lookup. Return it from a cache if it's available in a cache, and if it's not, then go to the database, go to the actual method call. So we have the @cacheable annotation, okay? It's very natural then to, I want to be able to take my service and actually expose it. It doesn't matter how many, if you build a really great service in the woods and nobody connects to it, did you actually build that service? It's a very, very existential question. And the answer is no. No, they did not. Because you need to, you have to expose this for people to use. And the way to do that today, the common way is to use the web, right? Exposing a web service or a Restful web service. Not the WS star kind, not the scary one, right? So here's a Restful service. It's a Spring Mvc controller. You can tell because it says @controller. And in that controller, we've injected a reference to our service object. And then I've got a method here that is going to be exposed to HTTP requests coming in at the URL /customer / and then it's expecting for the ID parameter, it's expecting some sort of value, like a 5 or a 10 or something, some integer. And that value will be made available to Spring Mvc as an argument parameter, as a path variable. And that path variable parameter we can use to call into the service, look up the object, and that object is returned from the RESTful controller as the response, okay? Spring Mvc will attempt to marshal that response and represent it in some way that the client can use, for example, JSON or XML. So, okay, moving very, very quickly, right? Very, very broad, sort of 80% case, right? Of course, the next question is, well, where did that Sessionfactory come from, right? For example, I used a couple of things in there, and we'll see more about that later. But in specific, that Sessionfactory, where did that come from, right? And of course, you guys know the answer. You have to configure it. Somewhere it has to be described. You have to describe it to Spring and say, hey, this is the Sessionfactory I want. Here's the data source it should use. And there's lots of ways to do that, of course. You can use XML. We all know about XML. So here, for example, is an public static void main. Contrary to what you've read, public static void main isn't dead. It's just dormant, okay? So here's an application context, class path XML application context. The string is a reference to the file, and we call the service. We access the bean and then call it from there. You can also use Java config, okay? So instead of specifying an XML resource, you can actually just specify a class which has Java-based configuration. We'll look at that in more detail here, right? That configuration can be used in the same way, basically. You're just using a different subtype of application context. But in every other way, it's the same thing from the consumer perspective, okay? So here's an example of a sort of an XML-based Spring application context. Very, 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 very typical. We've seen, I'm sure, something like this before. You've got beans at the very top there, and you've turned on certain features at the very top. Remember, Spring provides a lot of power, but very, very little opinion, very, very little sort of expectations. We don't impose any particular approach on you, but we do make it very easy to take advantage of certain things. So for example, I want declarative transaction management. Earlier on, we saw @transactional. The @transactional turns on transaction management so that whenever somebody calls a method, it's wrapped in a transaction, and all the transactional resources that are used inside, for example, the Sessionfactory, participate in that transaction. To have that feature, to have that functionality, you simply say tx::annotation driven, and you provided a reference to the transaction manager. I want Spring Mvc. I want Spring to find all the beans inside of a package. I don't want to have to register everything. I can just register certain things in my context. So for here, for example, I have context component scan, and I'm telling it to scan a package. I've got context property placeholder. This tells Spring Mvc to read the property file and make those property values available for use in my application. As in my application context, you can see at the very bottom there, I've got $ds.user. That's a substitution, right? That value will be substituted at runtime for the property that's in the property file. We've got a transaction manager, which in turn depends. It requires a reference to the Sessionfactory, so we just say ref Sessionfactory, and then we reference that. And then, of course, the Sessionfactory will at some point depend on the data source, though I haven't, displayed that here. So we understand that, right? Everybody, any questions on that before we carry on? Okay. So back to basics. Let's start from nothing. Here's a regular XML document, just a beans element, yeah? Here's the equivalent Java configuration. It's just at configuration and then a class name, public class foo, right? In this case, it's public class services configuration. As I reintroduce certain features, for example, I want to be able to introduce declarative transaction handling. I can say tx::annotation driven in my XML. In the Java configuration world, right, I can use @enable transaction management. So this is one example of something that's new inside of Spring 3.1, right? We've had this project called Java Config since 2005 as a separate project outside of the Spring core. In Spring 3.0, we consolidated that project. We merged it into the core, and now you can use it as a way of describing your beans. One thing that we lacked, one thing that was missing, was the analogous support for activating certain features. In this case, activating transaction management with @enable transaction management. So we have @enable transaction management now. And whereas before we had to specifically point to a bean ID, here it's just based on types. So I can just I just create a bean definition in my class. I say @bean public, in this case, platform transaction manager. And then I and I have a method, and then I return an instance of a bean. That method will be invoked when Spring starts up. And the return value will be stored in the context, just as if you had described the bean in the XML. So the basic behavior of Spring is still there. You have a bunch of bean definitions, and you have an ID and a type by which you can look up those bean definitions. It's just that now we're providing those definitions ourselves instead of letting Spring read the XML and then instantiate the beans for us. One thing that's interesting, that transaction manager is going to depend on the Sessionfactory, okay? The Sessionfactory is another method in the class. We have it down there. I haven't highlighted it. But for me to get a reference to that bean, I don't have to, I can just call the method. If I want a reference to that bean, I just call the method and get the return value. Spring will intercept the call, guarantee that the bean has been constructed in compliance with scopes and all that. So if you have singleton or prototype, those rules are respected. And then that reference is what's provided and made available for injection here. So even if I called Sessionfactory, the method, 100 times, I'd still get one bean created. So, you don't have to you don't have to worry about performance problems or anything. It looks like it's going to make a direct call, but it's actually doing a little bit of magic, sorcery, if you will, to trap the call, check the context. If the context has it, it returns it. If it doesn't, it creates it, satisfies all the dependencies, provides all the lifecycle guarantees, and then returns the fully instantiated configured object. There's an alternative style, alternative approach. In this case, I'm just calling a method. I'm just saying this.Sessionfactory, and the return value is given to me. I can also optionally declare an argument instead. I can say, hey, Spring, I want a reference to a Sessionfactory that Spring has configured somewhere. And this is very handy, for example, if you have an application that spans Java configuration and XML, and other modules, and you just know you have a Sessionfactory out there somewhere. You just want that one. You can use @qualifier annotations to specify that I want this one based on this ID, or I want this one based on this type combination. But broadly, this is another way of doing the same thing. Okay. Okay. So back to this. Another thing we had in the XML is the component scan. So you see context::component scan at the top. Context::component scan looks in the package, as I said, looks for all beans with @controller or @service or @component or @repository, instantiates them, and then makes them available for injection and so on. You can do the same thing using the annotations in Spring 3.1. So @component scan at the top. In this case, we're not going to specify a hard-coded string for a package. We could. There's an alternative attribute we could use here. But instead, we're going to specify base package classes and then provide a one or more class references. And Spring will look at the class and derive the package itself and then search for all beans inside the package and then below it. Another thing that we did before, we had a property placeholder replacement here. So I've got a config.properties file, and I'm using ds.user inside the property values in my XML. I can achieve the same effect by using @property_source, the annotation on my configuration class, and at the top, and I'm saying go ahead and load the property values in @properties in config.properties, and then I inject a reference to something called the environment object. I can use the environment object to look up properties and then configure my object. In this case, I'm going to set the username on my data source by resolving the property using the environment object. Same effect, right? You have a property file externally loaded, and you load it in, and you use it to configure your object. Another common thing, of course, is the Sessionfactory. You need that, right? We looked at that a little bit earlier. You would just define that just as you would any other way, right? So okay. So that's kind of very, very, very quickly. We looked at a service. We looked at a basic transactional sort of line of business code dealing with a data source, and then we looked at the RESTful stuff, and then we looked at how to configure that application. If there's anything you should see here, it's that it's all just Java, right? It's just very, very simple Java configuration, all very simple Java code. You can use XML if you like. It's still very, very supported. I just think a lot of people, don't know about the Java configuration support. Another feature we introduced inside of 3.1 is the test. We've upgraded the test context framework. So, for example, if you want to work with those aforementioned profiles inside of your tests, you simply use @active profiles in your test class, your JUnit tests, and the context loader, in this case, will be the annotation config context loader, the JUnit context loader, and we tell it to look at these Java configuration classes. Spring will bootstrap those configuration classes and make those beans available, and then you can inject the references to beans in that context in your unit test and then exercise them just like you would before, okay? And this also works with profiles as we see. Another very nice feature inside of 3.1 is the cache abstraction. The cache abstraction provides two very key interfaces, Cache Manager and Cache. Cache Manager has the ability to give you references to cache instances. Okay, a cache corresponds to a region in a cache. It corresponds to some sort of similarly behaved section of memory in your cache. Up until Spring 3.0, we had the org.springframework.cache package, but it was kind of empty. We had a few utility classes concerning EHCache support, but really the full potential, we didn't quite reach it, right? So with Spring 3.1, we rectified that in a big way. This new abstraction ships with a few different implementations out of the box. And of course, depending on what you're trying to do, for example, if you're trying to use this abstraction with Infinispan, JBoss is Infinispan, they have an implementation of this API. If you're using Hazelcast or Gemfire or Redis or EHCache or Coherence or whatever, there's an API out there for you, an implementation of this class. So if it's not provided in the core framework, it's provided by third parties. But either way, it's very easy to plug in your cache of choice. Memcache, that's another one I forgot to mention, Memcache D. Okay. So here's an example, okay? Suppose you have a service interface or a service implementation, and you've got various methods, and they need to look up objects in the database. It's very simple to say @cacheable, look up the owner. The effect here is that the method, when called, will generate a key based on the arguments. The key will be used to look up any objects in the corresponding cache manager, in the cache, owned by the cache manager. If it finds it, it'll return that object for you and short circuit the call. If it doesn't find it, it'll call the method for you. Okay, so in this case, if the ID is 5, it'll look up a record whose key is 5 in the cache. I can specify more complex things. I can say, okay, well, I want it to be stored in the owner's region, but I want the condition, based on the Spring expression language, I want this condition to be evaluated whenever I call this method. So if the name is less than 10, then go ahead and call this. If it's not, then I don't want, go ahead and just call the database. This is kind of nonsensical. But the Spring expression language is very powerful. You could, check the constellation of the moon and the stars. You could do whatever you want, right? Is my point. You have access to anything. You have access to any of your beans in the Spring context. The corresponding use cases, of course, supported. You can delete records. You can evict records from the cache based on delete or operations in your database. So here I'm saying @cache evict. Whenever somebody calls delete owners with ID 5, the previous entry that was stored with ID 5 will be evicted from the cache. So you get, you don't have to worry about dirty reads. Servlet 3 support in Spring 3.1 is very, very nice, right? So we brought it up to compliance with very common application servers at the time, like Tomcat 7 and Glassfish 3. We took advantage of the ability to create XML, web.xml free applications, so you can just use a initializer class. And we also provided support for Java config all the way through. So it's the web experience inside of Spring got really nice inside of 3.0. Another big thing was at that time, we put the Spring framework itself on GitHub. So all these projects are now on GitHub. All of the Spring Source stuff is on GitHub. Feel free to fork us. We like it. And this is actually only increased our community activity, which is incredible because we've already got, it's Spring. It's huge. It's everywhere. So people are very active now. It's very nice. This community model is amazing. All right. So 3.2. Kind of looking at this now. Okay. So this was last year. We had hoped when we set out upon 3.2 to include Java SE8 and Java EE7 support, right, to bring up compliance levels with those platforms. And we had also hoped to improve our Spring and Servlet 3.0 story, right, to take full advantage of that inside of Spring MVC. And we had hoped to just generally improve we had certain features, but in a big way, we were kind of hoping to depend on Java SE8 and Java EE7. And those were late. Actually, they're not just a little late. They're now going on several years worth of late. So it wasn't sensible for us to try and wait for them to ship because, I don't know when. I talked about Java 8 3 years ago. This is an old thing now. So the hope is that it'll be available this year, both of these things, and we can support them. We're pretty good about, if there's something that we need. For example, with Spring 3.0, Spring 3.0 shipped in 2009. Java EE6 shipped it was 2 days before that. And once it was GA and stable, we released. So we track these things as aggressively as we can and go, but we couldn't bet on it this time. So Spring 3.2 has a lot of nice features, but it didn't include the big chunks that we were hoping for. We upgraded our build to Gradle. How many of you guys are using Gradle? This is, I don't expect you guys to consume. You don't need Gradle. You don't need it, by the way. You can use whatever you want, Maven, Ant, whatever. But the nice thing about using Gradle for the Spring framework is that now, if you were so inspired, you could go to GitHub, git clone it, and then Gradle build it. You can actually build your own Spring framework. This is really awesome for me because the Spring framework used to use this very, very horrible, monstrous, disgusting, dream-killing, soul-annihilating build. This build was very, very fragile, and there's a good reason, of course. Most projects, contrary to what you might imagine, are not snowflakes. They really can be solved by a pretty conventional set of builds. Spring, on the other hand, supports multiple ranges of incompatible ranges of APIs, right? There's a reason Spring supports Hibernate 2 and 3 and 4, right? In the same implementation. We try and provide as much backwards compatibility as we can, If you built your application using Spring in 2004 and you were suddenly prompted to drop in the new Spring 3.0 stuff, it would still work. That's because we have very good backwards compatibility. If you had done it with any other platform, you would have had to rewrite it 2 or 3 times. But to do that, we have to do a lot of testing. We have to do a lot of dancing around incompatible interfaces in our code, a lot of reflective tests for variables and things like that. And this tends to make things like build tools very angry. They get very, very upset when you try and do this. So the fact that we're able to take this monstrous build, move it over to Gradle, and use it is very, very nice. We started building against Java 7, supporting Java 5, of course, as a baseline. You can use Java 5, 6, or 7, or 8 in theory, but we upgraded our ASM and CGlib support, added a whole bunch of features to Spring MVC, including async support, and generally improved a lot of, we fixed a lot of bugs and so on. So let's look at some of the MVC stuff. This is actually, I think, the nicest part about Spring 3.2. One thing we did was we supported the @async support in Servlet 3.0. So how many of you guys have played with Servlet 3.0 environments yet? Oh, guys. Really? Oh, as soon as you're done with this talk, go out and download Tomcat 7. It's a boon. It's huge. It's a win. Historically, the idea is, okay, I've got a web server. The Servlet spec was built on this idea that I've got a web server. It's going to stand there, listen on a server socket for requests that come in. And as soon as requests come in, a thread is spun off to handle the request and then deliver the response, all in situ, right? So the response and the request and the response are all handled in place in the same thread. This model works assuming that requests are ephemeral and short-lived, right? Otherwise, you have a bunch of threads being monopolized by long-lived requests. This is really, really bad for scalability. And as it turns out, we actually need long-lived requests. The internet right now is the internet of long-lived requests. It's chat systems, it's stock tickers, it's event-driven things that require long-lived connections. So this doesn't fare very well for our poor little Servlet spec and our servers. So of course, Java 1.4 introduced Java NIO, which introduced event-driven I/O, right, or NIO. And the idea here is, request comes in on a server socket. I have some sort of activity, but and I still have to listen, but I can only bother to act when the socket tells me something has happened. Okay, so I can ask for I/O. If there's no I/O, then I can just passivate. I can move my thread back to handle other things. To support this, of course, I now have to break the Servlet contract. Okay, so the contract before is do get and do post and so on. One method. This assumes that the thread that handles the request is the same thread that handles the response. In this new world, you have decoupled your request from your response. There is the thread that handles the request. It could be a very different thread than the one that handles the response. And if you are using this approach, you have to rewrite everything in servlets. So that sucks. But you get much better scalability. We've adopted Spring MVC to work on top of Servlet 3 if it's available. You don't have to, of course. You can still use the old Servlet 2.5 and 2.4. But this is very nice. So the support in Spring MVC looks kind of like this. Here's @request mapping. I have a resource, the upload method. Somebody posts to that resource. I calls this Spring MVC controller method. In this case, I have a multi-part file. So it could be Servlet 3.0 file, javax.servlet.part.part. Or it could just be Commons file upload, right? The Apache Commons file upload. Either way, I get a reference to a multi-part file and I can work with it. What I'm returning here is a callable. This is a subclass of runnable. It's basically just code wrapped inside of a body. And then that callable will be invoked in the background in a thread pool. Okay? As soon as it's finished, only then will Spring MVC bother activating the response buffer and then sending the response. So you can decouple. Again, this is very important. You can decouple the I/O from the threading. Another use case is, okay, I've got a thread that I need to listen to that lives outside of Spring MVC. Okay, you might imagine a stock thing. Some sort of event comes in on JMS, and you want to respond to it. To support this use case, you could set up a deferred result. Okay, so here somebody makes a request of the quotes URL. It's a GET request. That sets up a deferred result in some sort of global collection, for example. The global collection is updated by the JMS. You might imagine it being updated by some sort of JMS, queue or processor. And as soon as the JMS processor updates the deferred result and sets the data, that activates the response in Spring MVC. Okay? So again, make a request, add the deferred result, and then return the deferred result. From the client's perspective, nothing has changed, but on the server side, we're no longer stuck inside of Spring MVC. Now we just have this deferred result that may or may not have activity later on. And as soon as there's something that happens, Spring MVC will kick into action and then send the response for us. A slightly more specialized case of the callable example is the Async Task, which basically extends callable. It's a Spring MVC specific object, not just a Java SE object. Async Task lets you specify a task executor as well as a timeout value. But other than that, it behaves identically with the callable use case. Okay. Other things we did in 3.2, we've added content negotiation. We've made that a more pluggable strategy. So up to 3.2, with REST and our support in Spring, if you make a request against a RESTful resource inside of Spring, it checks the accept header. If the accept header says accepts application JSON, Spring MVC will endeavor to return a response using JSON. If you say application XML, it'll endeavor to return a response using XML. And this is par for the course with the web. This is pretty much the norm. It's a convention. But most apps, while they're well served with that approach, some wanted a little bit more flexibility. They want to be able to say, question mark, response equals XML, or they want to be able to say URL extension. So if it's .xml, serve XML. If it's .json, serve JSON. So all this stuff is now pluggable. You can use the content negotiation strategy to handle that. We added support for matrix variables. Matrix variables, well, basically, here are the two examples. At the top there, we have QA releases, semicolon, build number equals 135, semicolon. If you are parsing this and you're reparsing it and you're not sure what's going on, the only thing that's changed is that we're using semicolons in lieu of ampersands, all right? So, and this is actually supported by HTTP. It's not very common, but it's still out there. And now you can encode this inside of Spring MVC. So here I say QA releases, build number equals 135, revision equals 32. In the bottom, I'm using semicolons to create kind of a list. I'm saying value 1, 2, 3, 4, as a parameter. You can describe that now inside of Spring MVC controllers. You can say path variable, blah, 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 and then matrix variable. So it'll pluck the Q matrix variable from the request and then make it available as an argument in that method controller. Okay? It works identically as you might expect a path variable or a request param to work. It just provides support for that specific use case. These examples, by the way, are actually the top one is from JFrog, a repository manager. So that's an API that's out there in the wild that actually uses matrix variables. The one on the bottom is from the Stack Exchange API, the Stack Overflow basically API. So they're out there, but it's just I had to struggle to find these examples, If you want to get access to all the variables, so for example, Q equals 11, R equals 12, you want that as a map, just declare a map of type string, and Spring MVC will put all the variables for you in that argument. And of course, you can decouple the name of the variable from the name of the matrix variable. So here I'm actually specifying the value and the path var. I'm specifying that even though I'm using a variable called Q1, I expect you to pluck the matrix variable called Q. We introduced a very, very, very improved test framework for web applications. Okay, we've already had support for. We've always had support for taking a controller and then unit testing it. Ideally, you've written your unit test independent of the Servlet API, and if you have, then it's now free to. You can unit test it and easily plug in values. Right? That's everything we've seen so far. Is steered pretty clear of the Servlet API. You haven't actually seen any Servlet classes, so in theory, these are very unit testable. The mock MVC test framework lets you use the live dispatcher servlet, start up all your application context beans, and then delegate to that and actually execute calls against your controllers. So it's not actually starting up a full HTTP server, but it is going to execute your beans as though they were being run inside of a request. This lets you actually see how your beans behave in the web under test without the cost of running a whole web server. Okay, so here we have the mock MVC, right? We have mock MVC object that we got from Spring. We've created a reference of that by telling the Spring MVC support by these mock MVC builders, these static imports. We've used that to create a mock MVC object, and then we can use the mock MVC object and the static imports and the sort of fluid DSL to actually exercise our endpoints. We can say, go ahead and make a GET request against foo, and as a header, say that we accept application JSON, and expect that the response in this case is HTTP 200 or OK, et cetera, et cetera. So you can kind of see how this would be very useful. This is a controller-centric perspective. Another thing we have is also support for a mock RESTful server, right? So we can actually use the REST template here and make calls to this mock server and exercise that the responses we've gotten from the server comply with what we expect, that the payload of the response is what we expect. So this is very, very powerful as well. Let's see. Okay. Whew. I'm sprinting through all this just to make sure we're all on the same page. We have a little bit more to cover. But so far, how are we doing for questions? Do you have like 5, 10, 100, 1,000? Even I have questions. I was here. Can't imagine you guys don't. Do you have any questions? Okay. Feel free to ping me afterwards, but we do want to get through this. So Spring 4, as I mentioned, is due at the end of this year. We're going to up our levels for Java 8 support, right? So Java 8 and Java EE 7. We're going to have themes. We always have themes when we do these releases, right? Things that we're trying to focus on across the framework, right? So message-oriented applications and architectures, that's a big theme. Web-style messaging in particular, WebSockets, etc. We're going to also keep another theme is Java 8 support and Java EE 7, so we'll see that. We'll see improved Groovy language support, and other things as well. If you are curious as to what's happening and what major themes there are, feel free to follow the Jira. We're actually going through the process of sort of describing what this means to us, what we want to see in this release right now. So that's happening. If you go to Jira and you see something interesting, please feel free to chime in or volunteer what you expect or whatever. When it comes to Java SE 8 and Java EE 7, Java 8 actually is a really, really interesting proposition, I think. How many of you guys are using Java 7? See, it's nice, right? Actually, very nice language. Java 8, I think, is going to be amazing. Lambda support in particular is going to be a really, really nice win. One nice bit about the Java 8 support is that all single argument methods, all interfaces that have one method, as is typical for callback classes, are immediately eligible to be converted into lambdas. Okay, so you see in Spring Mvc all this callback-oriented code where you pass in an anonymous inner class that implements an interface simply so that Spring Mvc has a method that it can call, the template pattern, right? We see this all the time, the JDBC template, JMS template, etc. Well, all that code just automatically works as lambdas. So suddenly you can just remove these anonymous inner classes and just use lambda, closures. Very, very, very cool. We'll see improved date and time support. Stephen Colburn's JSR 310, right? That'll be inside of a Java SE 8. That's very, very good. We've already got support in Spring for validation and conversion of basic Java.util dates as well as Joda time dates. So this is just another stake in the ground. It's just another version of that, another way of doing that. We'll have finally in the core, we'll have support for NIO HTTP, and you'll see that support bubble up inside the REST template, which can be used to make short work of HTTP calls, one-liners. We'll see the Java.util concurrent stuff grow, and we'll see that support reflected in the task executor stuff that Spring provides as well. For Java EE 7, of course, we have JCache, JSR 107. We already looked at the Spring cache abstraction. Well, as of 3.2, we provided an implementation of JSR 107 as well. So if you have a JSR 107 implementation, even though it hasn't shipped yet and it's not GA, you can use that API from Spring. You can actually use Java EE 7 from Spring before Java EE 7 is ready. JMS 2.0, JPA 2.1, JTA 1.2, all this stuff, we're going to support it wherever we can. And of course, we will compile against Java 8, our code. You don't have to. You can still use Java 5, right? Here's an example of annotation-driven, declarative JMS endpoints. If you've used any of the other Spring projects, in particular if you've used Spring integration, then having this support is sort of like, oh, great, what to do, because we've already got it, right? You've already got support for declarative listeners based on events, be it JMS or MQP or XMPP or FTP or file or whatever, Twitter. Another very interesting part of the new platform is WebSocket support. WebSocket support isn't currently standardized yet, but it's going to be, JSR 3.5.6. We expect to see a lot of the application servers rush to support it very quickly if they don't already. And we expect to be able to support that inside of Spring 4, what we were calling Spring 3.3. Forgive the faux pas, the gaffe here. broadly, we'll also see that support in Spring integration, our integration technology, the message-driven architecture framework for Spring. Caching, right? This is again, we haven't done this part yet. This is actually another thing where we could use your feedback. We are looking at different strategies for resource processing, okay, in web applications. Often it's very typical to see an application where you've got maybe 5 or 10 different JavaScript files that live independent of each other and that are very, very sparsely, lots of white space and all that stuff. It's very typical to have some sort of compiler step to merge all these JavaScript files into one thing and then minify it. And then that's what's used in production. But in development, you still want all the independent, very unminified code because you want to be able to step through it and see what's going on. We expect to support that kind of life cycle, that kind of processing inside of Spring Mvc. So when you boot up, when Spring Mvc starts up, the application framework, it'll process these things for you, depending on what profile you've got active, for example. You might, in development, leave everything off, but in production, you want it to be as compact and minified as possible. Another example is CSS. How many of you have used the LESS language for CSS? It's a grammar on top of CSS that makes it very, very simple to do things that you couldn't, without a lot of work, do inside of raw CSS. So you want to be able to process less grammar and then convert it into CSS, right? That's another thing you can imagine plugging into this pipeline. TypeScript, that's another one. Or CoffeeScript. These are other grammars, other languages for JavaScript that you want to compile and convert into JavaScript at production. So again, we can expect, we're looking at ways to support these various use cases. We've already got MVC resources in Spring MVC. This sets up e-tags, basically, expiration dates and all that, and expiration headers in your resources. As it is, this support will be folded into this broader theme of improving application resources, okay? It'll be similar, we think, to the Rails resource pipeline or the Rails asset pipeline, in that vein, I mentioned enhanced Groovy support. The Groovy bean builder should make it into Spring 4, right? This is one of those generically useful, wonderful little classes that makes it very easy to build Spring application context using Groovy. Remember, as far as Spring is concerned, all of these are these are all just import formats. At the end of the day, what happens when Spring starts up is that it creates this big giant bag of beans. Those beans live in this container. They can all access services provided by Spring. They all live in the same context. They can all be injected into each other. There's only one type of bean. There's no, this is not a Servlet bean. This is not an EJB. This is not whatever. They can all share the same world, But whether the beans are described in XML or Java configuration or via conventions and annotations or via Groovy or via Scala, Spring doesn't care. It just needs to know about which bean, which ID, which type, etc. Right? So Groovy Bean Builder is another way of doing that. Let's see. I think. Yeah, good. Okay, guys. So that, in a frenzied hurry, is a look at Spring 3.1, 3.2, and the new stuff in 4.0. Now, any questions? We do have time, thankfully. Yeah? No. Are they going to support us? I don't know. I mean, so Spring MVC's support for REST is, well, first of all, it predates JaxRS, but it's also more idiomatic and natural for Spring users, right? It's again, I mentioned that component model thing before. If you're already using Spring MVC and you want to support RESTful endpoints, just add @response_body to your return value, and now you have a RESTful endpoint. We've already got request-to-response processing on the web. We've got that use case very well satisfied, and we've had it for years. So as we saw earlier, it's very natural to just add that little annotation, and now your response can be represented as a RESTful resource. Conversely, you can actually say request body. So instead of a return value, you have the argument coming in. So if you submit JSON to the server and you have an argument in your Spring MVC controller method saying request body, it'll convert the JSON into your Java object and make that available. So it doesn't make sense to introduce a whole new component model that doesn't know about anything else. There are more users using Spring Mvc than JaxRS, and they're better served by this integration. We support everything that JaxRS supports, and actually a lot more, right? Because we have, in addition to the Spring Core stuff, we have Spring Security OAuth for securing with OAuth RESTful services. We have Spring Social, which provides the ability to connect to OAuth 1.0, 1.0a, and 2.0 based services like Facebook, Twitter, and whatever, and arbitrary ones. You can build your own. If you go to the wiki on GitHub for Spring Social, you'll see like 30 different Spring Social providers, which provide API, type-safe APIs built on the top of this common platform for connecting to RESTful services. We have something called Spring Data REST, which exposes Spring repository objects, basically data objects, data services, etc. It exposes those as RESTful endpoints for you transparently. We have another project called Spring HATEOAS, which is hypertext as the application of engine state. This is a very well-known design pattern in the RESTful world, and we support it out of the box on top of Spring MVC. Okay, so the design pattern is basically, if I go to / in my application, that should be the only known URL. I should be able to navigate by inspection the entire application from there. Based on, so I make a request, it gives you basically a menu of links, and you follow the links accordingly, right? The canonical example is the Starbucks cafe example. I go to the / I say I want to order a drink. It says, here's your menu. Post to this URL to order something. It expects a structure like this. You do that, it gives you a response along with more menus, right? So that's a design pattern that you can support inside of Spring MVC. So, and we have Cujo.js, which is actually a whole bunch of JavaScript support. Very, very clean, interceptor-based, very REST template-centric client-side libraries for JavaScript. And we have Spring Android, which provides support for consuming RESTful services in Android very, very cleanly, right? Using the same REST template that's in Spring Core. We have the best REST support in the industry. There's nothing even close. So I don't see us supporting JaxRS, but I could be. If enough people all converged on the Jira and said we demand it, maybe. I don't know. I don't think so though. It would be a step backwards for most people. See what I'm saying? Yeah. Any other questions? Yeah. No. We don't deprecate stuff like that. We don't break APIs, unlike the other guys. We keep our stuff working. So you don't need it, right? As we speak, Spring Batch, Spring Social, Spring Security, Spring Integration, Spring MVC, of course, Spring Core, all support just Java configuration, right? They all have APIs for that. Some of this stuff is not finalized yet, like the Spring Batch stuff is not done yet, but it's there, right? And you can use Spring Core, so you don't need to use. So, not that I don't think so, but Oh, well, so we have, if you look at our build, it's actually like, we have a lot of jars, but they're all very small, lightweight jars. You can just exclude jars. You don't need the whole thing. So if you just want the core context, that's fine. I don't know anybody who got promoted or who got a big contract just because they're using dependency injection, though. So invariably, people bring in other things like data access support, or they bring in the MVC stuff, or stuff that actually delivers value, The dependency injection itself is just sort of a means to an end, right? We happen to be very flexible. We support lots of different styles, but it's just a means to an end. So you can bring in and exclude as little or as much as you want. That's you don't have to you don't have to like consume everything, So, but as for shipping a build that doesn't, you could just make it so that they can't use class path XML application context. I mean, I don't know how to get rid of it completely. I'm open to ideas. We have a very, very, very good Jira, and we're very focused on our users. So please, if it's really a strong concern, and if you have a pull request, I love pull requests. We love it. All right. Any other questions? Yeah. Mhm. You do. That's the default behavior, right? It might if the cache is down. Well, okay. So playing this out in my head, if the cache is down, Spring is going to try and connect to the Redis provider. It's up to the implementation of the cache manager what happens in that use case. But there's no reason you couldn't override or provide a wrapping cache manager that you use instead that simply times out based on certain calls, right? So remember, when Spring sees the add cacheable, it consults the cache manager. Cache manager says, "Oh, I've got a request. I'm going to look in the cache, and then try and bring up the resource." You could just short circuit that. You see what I'm saying? I mean, but how you would do that for Redis versus Gemfire versus Coherence versus whatever is. Hmm? Yeah, but I'm saying that would have to change per. That's nothing that Spring does there. It's just does the client driver that connects to Redis, is it smart enough to disconnect after 10 seconds of no activity? I mean, that's specific to that driver. It's specific to the client of that cache. See what I'm saying? I don't know what it does actually if the cache is down. But my point is you would handle it by providing a different implementation of Cache Manager. So I would try it there. I don't know what your specific use case is or what it looks like. No, just a Cache Manager. Just provide a delegate, something that delegates to these others. So if, wrap the method calls in timeouts or some sort of a logic to trap the exceptions and then just let the method call go through, for example. So expiration is another thing where it's specific to each cache. There's no way for us to configure that because this is region-specific stuff. This is not stuff that most caches expose in their API. This is stuff that they can expose in their when you set up the cache itself. This is just the Spring at cacheable abstraction is just the client side to somebody else's cache. It's a client perspective to a cache. We don't administer or set up or install or configure your cache for you. So if you want to set up Gemfire or Coherence, whatever, that's a separate ball of wax. You see what I'm saying? Sure. If you do have ideas about the retrying or disconnecting or doing the right thing, please, Jira. I don't know of any plans to support a specific use case, but if it really is a legitimate concern and there's a way that we can do it in such a fashion that it serves all the implementations, we're very open to that, of course. So please, feel free to reach out on Jira. We love Jira. And you'll get our attention. That's definitely a good way. You file bugs, people listen. So please, yeah. Other questions, my friends? Anybody? Going once? Going twice? My Twitter coordinates at StarbucksMan, josh.long@springsource.com if you have questions above and beyond what we've discussed here. Thank you so much. Have a lovely day. Thanks for the good time. Cheers.